Hi everyone. I'm Yosi from data science team in Apiro, and I will talk to you today about matching runtime traffic to code APIs using model. All right. Yeah, this is the agenda of the talk. There will be time for questions, as you know. But if something is really unclear, please ask me on the spot. Okay, so a couple of definitions first of all. We'll define endpoints. Nowadays, large services are implemented with small microservices that are running in the cloud that interact with each other with the traffic. Sniffing tools are monitoring the traffic for the purpose of traffic security and workload management and other purposes. And they extract all the properties of this traffic. There can be different kinds of traffic and talk between services. gRPC, can be SOAP, GraphQL, but we'll talk only about REST HTTP requests in this talk. Also, this traffic can be from outside users, and there are rerouting rules in between. So all this traffic that is provided by sniffing tools is endpoints that you should just know in the scope of this talk. The other thing is the corresponding pieces of code that are handling this traffic and these requests, and we'll call them APIs or code APIs. These are actually the controllers that are responsible for the endpoints, and that is the second definition you have to remember. So endpoints is network traffic detected by sniffing tools, and code APIs is controllers, pieces of code that handle incoming HTTP requests that are defined by the code of the customer of Apiro. Why do we need it? We need it for two main reasons. Application security engineers that, for example, are given a specific endpoint which has a vulnerability, would like to know who is the person in the company that is responsible to fixing that. And that's not easy to know because there's only can be one application security engineer for the entire company, which has thousands of repositories, and it's difficult to know exactly which person is responsible for which piece of code. However, if that endpoint has a matching API, and we know what piece of code is responsible for that endpoint, we can also know who's the developer that can fix the vulnerability of the endpoint. So that is one direction. The second direction is, the second direction is that, again, application security engineers not always know what repositories are deployed and used and what are not, because there can be, again, thousands of repositories in a company. But if there's a repository that contains an endpoint, and we know that that endpoint has a corresponding, a matching endpoint, then we know that that repository is indeed deployed. And if that repository has some other vulnerabilities, such as secret in code, then we know that secret in code gets higher priority in remediation. So that's why we need the matching between endpoints and APIs. That's the goal of our task that I'm dealing with. So this task of matching between endpoints and APIs has many challenges. One challenge is that not all routes of the endpoints match exactly the routes of the APIs. Why is that? Because there's, for example, sometimes rerouting infrastructure that is not part of the defined API, that is defined in configuration in the cloud or in other pieces of code outside of API definition. And it's not just obvious matching of routes. Another challenge is that there can be contradicting signals for matching. For example, here we have 2 endpoints and 2 APIs, and each of these endpoints matches each of these APIs in different ways. The first endpoint matches the first API in the way the body is built here, and matches the second API in the route, which is identical. And the second endpoint matches also both of these APIs, but in the opposite ways. So which endpoint matches which API? That's unclear. Another challenge is clustering of endpoints. In this example, there are 2 endpoints that have routes, where the middle segment of the route is actually a parameter. The EU and the US middle parameter are actually called by the definition of the API as a parameter, but endpoints in this case are not grouped by the sniffing tools and provided to us as different endpoints, and also the route doesn't match. Sometimes sniffing tools know how to cluster them, but sometimes not, and that's also a challenge. Also, there's a challenge of partial properties detection, which means that the properties that the API expects, for example, the request body or the query parameters, is not always defined explicitly in code, but sometimes as an object. But sometimes it is the logic of the code that defines what query parameters the API expects. So the result is that when we scan and extract APIs, and we don't have all the properties that this API expect to get, and that's also a challenge. For example, in this case, there's an endpoint with some body schema and 2 APIs that could be matched, but we don't know which is the correct one. Another challenge in the matching is that not all APIs and endpoints are expected to be matched, even in the best case scenario. For some reasons, not all APIs are expected to be matched to all endpoints, because not necessarily all traffic in the cloud is monitored by sniffing tools. Another reason is that there can be APIs that are deployed but not used by the customer for his own reasons. Also, not all endpoints are expected to be matched to all APIs, since, for example, the customer doesn't monitor all of its repositories that it provides to Apiro, and Apiro doesn't know all the APIs that are available at the customer's entire repository set. And there can be unknown APIs that just the customer doesn't want to provide us with. Also, there can be running applications in the cloud of third parties that neither Apiro nor the customer has its code, and we don't know their APIs, of course, also, and their properties, and we cannot match these endpoints to the correct APIs. Okay, so there can be different approaches of matching endpoints and APIs. One is a heuristic algorithm that we tried, and its caveat is that complexity of the algorithm and maintenance, which is more complex. Another approach is using LLM services of generative LLMs such as ChatGPT. But a caveat of it is that there's data privacy concerns. We wouldn't want to send third-party code of our customers. It's proprietary code, and also it's costly. Also, well, we tried also using open source generative LLMs, but the quality wasn't good enough. And also there's the question of what's the input to the model if we choose to use a model, because there are many endpoints and many APIs. There can be thousands of endpoints and tens of thousands of APIs for every customer. And if we use a model, what is the input to it? Is it all endpoints and all APIs, and then asking him what are the matches, or providing it with a single endpoint and all the APIs, and then asking what is the correct matching API? Well, in both cases, it is not feasible since there's just too much information. We have to provide the model with all the properties of the endpoints, the route, the query parameters, and also the properties of the APIs, what they expect, what query parameters, what body parameters, etc. And there are not enough. Well, current models cannot handle that much of information. So the solution that we chose was treating it as a classification problem, not as a matching problem, and using two steps. Does work? Using two steps for reducing the amount of candidates for each endpoint. Well, the first step was candidates retrieval, which was using a statistical function to find best matching APIs to every model that could be a match, but would not know whether it's a good match. And we're choosing up to 15 best matching APIs with that statistical function, which is very easy to implement and runs quickly and can be used for tens of thousands of APIs. And after that phase, we get for every endpoint only 15 API candidates of a match. And then we use a language model for giving a score for every of its candidates to know which is the best one and which is the correct match. So this is like a funnel. From thousands of APIs, we get only 15 candidates for every endpoint, and then choosing the best one using the model. Okay, so we use the BERT model, which is relatively modern, and there's the modern BERT, which we'll also start using. It's open source and trainable. It fits classification problems because of two entities, because of the way it was trained. It's lightweight, doesn't require a lot of resources, runs pretty fast. The caveat of it is that its input is short, and you can't input a lot of information into it. So this is the general flow of the solution. Data extraction, all the data of the APIs and endpoints, preprocessing it, clearing it, and normalizing the data. Candidate retrieval, which I just explained, but we'll dive deeper into it. BERT ranking, then getting a BERT for each of a rank for each of the candidates. There are additional features that I will also talk about, and finding the highest scored matching API, and that would be the correct API with some threshold. Okay, so the process of candidates retrieval is done in the following way. We're using best match 25, which is a very common ranking function for finding similarities between sets of documents and finding similar documents in two sets. Extracting all a bag of words for endpoint, which is all the strings from all of its properties, from the segments of the route, the strings, keys of request body, response body, query parameters, the headers, etc. And the same we do for the APIs, including the method declaration of the method of the API. We're selecting the 15 highest ranking APIs, and they are the candidates for a match for a given endpoint. So this stage we have up to 15 candidate APIs for each endpoint. Then every endpoint is using the model with each of its candidates separately. So if it has up to 15 candidates, there will be up to 15 requests to the model to get a score for a match, and we'll select the highest score with some threshold as the correct match. How do we use the BERT model? Just listing all the properties of the endpoint and all the properties of the API with a special separator between them, which marks to BERT the separation between the two parts of the BERT model. Well, we did that, and it worked well, but not good enough. For some reason that I'll explain why. There was some information that was lost in the way on that process. Let's consider this example of 3 endpoints and 3 APIs. And each endpoint here is listed next to the corresponding API as the correctly matching API, right? The first to the first, the second to the second, etc. So let's check how will BERT examine the candidates of the third endpoint, the one that ends with VIP user gift. So the endpoint is the same endpoint in all 3 cases, but there are 3 different API candidates. So in the first 2 cases, there are 2 strings that are common between the endpoint and the API. The API and the add strings are common in both cases, and BERT gives the score of 0.2. In the third case, however, there's only 1 string that matches, the VIP user gift. And since it's only 1 string, BERT gives it the score of 0.1. But we people know, right? Of course, you understand that that is the correct match, although it gets a lower score. Why is that? That is because the strings, we understand that the strings API and add are not very unique. They appear in many APIs and many endpoints, and they're not a good indication of a good match. However, the string VIP user gift here in the route of the endpoint and the route of the API, they exist only in 1 endpoint and 1 API, which means that they are the exact match, right? So does any one of you who is understood until now know what kind of mathematical method can we use, or I don't know, heuristic method to incorporate this notion, this human understanding into the model, into the computer?
TF2.
Yeah.
T5.
Yeah, that's right. Thank you. That's exactly that's the answer. So we added also a couple of TF-IDF kind of features together with the BERT model. Features were not an input to the BERT model, but next to it I will show you the final model. And so this is the final model. First step was candidate retrieval. We're getting the properties, the up to 15 API candidates for each endpoint. Each endpoint is inserted as input with corresponding API, possible API to BERT. The output is logits, and together with these special TF-IDF scores, we use a linear regression layer to get the final classification together with the softmax function and the final score of the match, how good the match was. So the current project status of the project is it's running periodically for some customers, and new customers are getting special treatment with human tagging and retraining of the model with its own target APIs and endpoints. For example, we had a new customer that had 13,000 endpoints and more than 4.5 APIs, and we managed to match a coverage of 77 endpoints out of them with precision of more than 90%. Also, it managed to match correctly to an endpoint and an API that had a route that had 2 segments two segment strings in opposite direction, sending active and active sending, which were opposite in the route of the endpoint and route of the API. Still, it was matched correctly, which is impressive. And also, there was a case of 114 vulnerable endpoints, which were matched to the same API. And actually, fixing that API helped to fix 114 endpoints in one fix. And so, what are the takeaways from what I just told you? Well, 1 is treating a matching problem as a classification problem. 2 is using 2-phase solution with candidates retrieval, which enables scale. Using contextual features that are lost on the way, that I talked about. And using BERT model for classifications, especially of 2 entities, since BERT was trained in that way also. And that's it. I hope you enjoyed. Thank you. Questions? Yes.
Did you have to do a whole bunch of transfer learning on the basic BERT model to tailor it to your task, or was it pretty light touch?
Well, I trained it, of course, just using the regular methods, and it was not that complex, as I understand.
You said that you're retraining the model for new customers. Do you have one model that you use for all the customers, or are you using a specific model for each customer that you retrain on their data?
Okay, so the question was whether we have a separate model for each customer, or do we use the same model for all of them. So currently we have the same model that we use for all of them, but who knows what the future brings.
So a new customer can help the other customers.
A new customer, yeah. So did you have a question?
Did you try to use, or did you consider using information from the runtime, like request tagging, that you have request ID headers from the end, from the client to the server? Do you have any access on this situation?
Okay, let me see if I understand the question. Whether we have some additional tagging of requests, that will help us to match the request, the traffic, to the specific server. Is that right? Is that the question?
Yeah.
So, yeah, well, that could be very helpful. We have some sniffing tools have a bit of what you're talking about. Some customers are marking some of the endpoints with the name, and that name can be indicative of an application, and we have also mappings of application which connects to APIs, etc. So in a way it is done sometimes, but it depends on the sniffing tools and the provider of the endpoints that he should enable it. And also the user itself has to use that option, and that doesn't always happen as well.
How often do you retrain your model, and how do you choose which data to use for the retraining?
Okay, how often do I retrain my model, and how do I choose which data to use?
A bunch of customers, and they can all spin up new APIs or endpoints, depending on whatever they like.
Yeah, well, all right. So we're training the model along the way. Like every time we have a new customer, and we have some new insights or way to improve the model, we're doing it like it's like a rolling process. It's not finalized yet. So every customer also we try to use most of data we have. So we're also using manual tagging, and the more data we're using, the better, right? So that's what we try to do. And do I have time for more questions? One more. Who is the lucky guy? No more questions? Okay, thank you very much then.